Review sheet C, question 1. We've now got a rough horizontal floor. So I'm going to draw a diagram here and put our mass. Our mass is 2 kilograms. And we can put our forces onto this. We've got a force here of 2G coming down, and we have our normal reaction force here. A string is attached to the box and it's pulling in this direction. So we've got some pull in this direction here, and that means we have an acceleration in that direction of 0.1 meters per second from here. There is a frictional force here pulling it backwards. So there's our diagram, and let's work through all of these bits as we work through. First of all, I'm going to go in the vertical direction, and you've got R pulling up and 2G going down, and that equals 0 there. So for the first thing, our normal reaction force is 2G. That means that this frictional force here is mu times 2G, because friction is less than or equal to mu times R, but as it's actually moving, it's actually going to be equal to mu times R, and we're told that the coefficient of friction is actually 0.5. So I've got 0.5 times 2G, so actually here I've got a frictional force of G going in that direction. Let's work this bit out then. So going to the right, we've got our force, take away the frictional force going back again there, and that's the resultant force. F equals ma equals the mass times the acceleration, which is 0.2. So P equals, 0.1. 2 times 0.1 is 0.2 plus the G. That gives me that the propelling force is 10 newtons, as you were told it was going to be there.